Idris, you can start the class. Hello, Idris, you can start the class.
Okay, all right, no problem. Good morning, guys.
Sir.
Yeah, good morning. So we are coming to the end. We are wrapping up already. So congratulations so far. So all right. So basically, what we are doing today is just a review of your test, and we can just talk about a few things, and I think we'll call it a day. So okay, let's start from the test submission. Have you been able to successfully submit the test? So okay, I want to apologize. I it was until late last night I got messages about issues with submitting. I'm sorry I had not replied, but have you guys been able to resolve some of those problems now?
We are just trying to resolve it. We have not resolved it.
Oh, okay. Someone mentioned that his assignment is in folders. I think you should be able to submit upload the file to something like is it Dropbox or let's say Google Drive, for instance. Make us allow anybody that has that file or downloads that file to have access, and you can submit the link on the channel on the on LMS. If you can't
Okay,
submit
sir.
an entire folder, yeah, that's for people that
Okay.
use something like Django or
Django.
yeah. Okay. But if you use maybe you have only a single Python file, though there are two questions, what you can do is to have all your code in one Python file. Though generally you want to have it in two, but you can actually submit two Python files. It doesn't matter. Okay, just name them properly. One for the I think Fibonacci sequence, and one for the to-do list. So it should be readable. All right. So now that we've done submitted, should we review the test or we should leave it? Okay. So let's talk about the test. So challenges, experiences, things that you learned while doing the tests or whatsoever. So you can share. Um, Hello, Josephine and Shay. Hello, can anybody hear me?
Yeah, we can hear you, sir.
So
So
I
we
Yes,
can
said,
yes,
hear
sir.
you.
all right. So I was saying that we need to review the test. So who is going first? I need to share your screen.
Linear. Which tests? I see all the tests or only the final test?
The final test, the final test.
Just
Not
the
all the.
final test.
Oh, do you have any other thing else you want to
I
ask?
have any other thing. I have only one thing.
Okay, what thing is that?
Linear regression.
Linear regression.
I don't
Okay.
understand that thing. Like, I don't understand that thing. That's the only
Okay.
issue I
And
have.
any other person?
Yeah, linear regression. I guess that was the only thing, but yeah, that's the thing that
That's the
it's not
thing. Oh.
it's not really it's not really clear, but
Understandable.
but,
Exactly.
Okay,
but
okay. Let me just give a brief explanation. So, the idea behind linear regression is you want to be able to find relationship between probably two variables you get or two different sets of data. Do you understand? So, for instance, if you have like in Nigeria's case scenario, the higher dollar goes, the more expensive things become, right? So let's assume that we did not know that before. Okay, so let's say in some places prices don't reduce, in some places prices increase, and all of that. Now you will now aggregate that data together. You understand? Now you want to show some kind of correlation, either positive or negative. That is, if it is positive, it means that okay, they have like a positive relationship. That is, if one goes up, the second one goes up, right? Then if it is negative, it means if one goes up, the other one reduces. So that's the general idea within linear regression. Now, regression in itself has its own mathematical formula. We Is not in the scope of this class. Okay, actually, in the intermediate class, you will get to actually know more about the linear regression. What this class was meant to do was to introduce you to the concept. Okay, so with the regression is linear, so it should be a straightforward graph or a straight line graph, okay? Because you are not comparing complicated relationships, just direct. So is either positive or negative and all of that, inverse, or they are directly proportional or related in that way. So there is a formula, okay, for linear regression. You can look it up. Do you understand? Now, there are tools that we use in Python to do some of these things. The main thing you need to understand is how to use it and how to work along with them. So if I let me share some amplifier material we can use to just talk about it. Like a linear regression in Python. Okay. Um, all right. Hey, can you see my screen?
Yes, we can see your screen, sir.
All right. So we are living in an area of large amount of data, powerful computers, plenty story. I will drop this link in the chat box. So learning is the fundamental of statistics, machine learning, and computing. Okay, so what do we use linear regression for? So regression searches for relationships between variables. So you can observe several employees of the same company and try to understand how their same salaries depend on their features, such as experience, education. So, like I've said before, we use regression to compare. Okay, does this have an effect on this, or does this not have effect on that? Now, another thing we should know is there are some times that regression, when you are comparing data, linear regression is not the go for case scenario, depending on how the data is. But let's just leave that out for the main time. But the main idea is you use linear linear regression to compare. Now, for a simple example is for house prices, number of bedrooms, and all of that. So you can say, yeah, you want to find out if the prices of an house depends on certain variables. For instance, so you can compare how does the bedrooms, number of bedrooms in the house affect the price? Does the location, does probably network availability, how civilized is that area? Do we have industrial areas? And it's actually like that in Lagos, actually. So if you're even just coming from another state to Lagos, then house prices go up. Then when you move into some places in Lagos State, then house prices becomes something else. So on the mainland, on the island, is almost like two different worlds in Lagos, right? And even within the mainland, when you get to places like Yaba, Ikeja, house prices also get elevated. Unlike when you are coming lower down to maybe Yampaja, Oshodi, and all of that. So you can use regression or linear regression to find relationships. Okay, is there a direct cause for why house prices increase in areas like Yaba, Ikeja compared to other areas? So you will look at different things that you might find interesting. Is it about electricity? Is it about proximity and all of that? So with linear regression, you will be able to tell that I think this is the cause, or this is the relationship, that this particular feature or this set of features is responsible, directly responsible or inversely responsible, or there's a positive correlation between this feature and the prices of houses. Okay, is there any questions so far?
No
No,
question.
no questions, sir. We are
Okay,
getting.
so that's like the goal of linear regression. That's actually what we are doing linear regression for. Okay, I know I didn't get to explain what we are doing linear regression for in the actual day we taught it, because we thought other things that day. I think it was that day we thought about get request and post request and all of that before proceeding to pandas, numpy. Then I tried to show you guys a quick example so that um, we could solve the problem. Now, a few things you need to know about I don't want us to go in depth with all these plenty grammar, but let's see. So what when you need regression, okay? So you need regression to answer whether how some phenomenon influences the other or how several variables are related. So we've talked about that. So to determine whether experience or gender impact salary, so you can want to compare. Now, linear regression is one of the most important and widely used regression techniques. It's also the simplest amongst regression methods. Okay, so problem formulation when implementing a linear regression, some dependent variable y, okay, which in most cases might be the price of the house, okay, on the set of independent variables where r is the number of predictors, right? So if you notice, I don't know if you finished, you're able to finish that assignment, that particular assignment, when I showed you how to do it with SciPy, you will notice that you got something like a R value and a P value. Does anybody remember? Hello? It's fine. We're at the end of the class. So do we remember having a R value or P value or something like that?
Like X and Y.
No, no, no. Okay, let me see.
Okay, like a prediction value.
Yes, because the command we used
Yeah.
back then, if I remember, was something say starts dot lean regress, something like that. And
Yeah, I
when we run
remember
that
you got
command,
a
yes,
predict.
it will give you five values, right?
Yes, I remember
We'll
that
get
part.
you will get the slope, we'll get the intercept, we'll get the standard deviation error, we'll get the standard deviation, and we also get the R value, which is the predictor. And I remember I mentioned that if we have a positive value for the R value or the predictor, it tells us that there's a positive relationship between them. Let me see if I can bring up that folder again so that we can just a refresher to where do I have that where do I have that particular okay. Please give me a moment. Not you. Okay. I think you should do it. So let me share my screen again. All right. All right. So I think my screen is visible right now. All right. So if I okay, it's taking a while. All right. Can we see my screen?
Yes, we can.
All right, so this is not the exact example we did in the last class. If you remember, in the last class we did something like doing some scaling where we normalize the data. That is, we spread the data between a range of particular set of values. I think we used 0 and 1, if I remember well, because we had differences between wait one sec, between the grades. I think it was the grades, yeah, the grades and study time. The grades was around 90, 80 and all of that. And we're having study time around 5, 4, 9 and all of that. So what we did was to use a method to kind of normalize data so that they are not far apart. But let me just use this example to show what I was saying. So If you notice, this is the way the result we had before was going to impact what we're doing. So we have a slope, intercept, R value, and P value, and all of that. Now, this R value is what we're talking about. I think the predictor that actually tells us if we have a relationship or a kind of good relationship. And I mentioned that if you have a positive relationship, so it's usually between 0 and 1. If I remember properly, in that class, we have something like 0.64 or 0.62 around that range. And I said that since we have a positive value, and that's actually a very high positive value, that we can actually say that the study time, at least the amount of time students studied, is kind of is perfectly related to their grade, and this one is actually 1. So there's kind of a positive relationship between them in both cases, and it's actually true. For instance, if you look at the values, you have 1, 2, 3, 4, 5, 6, 7, 8. Then you have 10, 20, 30, 40, 50, 60, 70. So the increment is perfectly uniform. Do you get what I'm saying?
Yes, sir.
Let me change these values a bit. If I adjust these values, for instance, so that we see, all right, so we are getting very different values right now. So we are seeing that our value is about 0.8. It's still positive. Do you understand? So if I did something like make it on the reverse, let's say 60, 40, okay, 30, 45, to 21, 10, and 35, okay. So let's see if we would have some kind of all right. So you're saying that our R value right now is negative. Okay, so we have an inverse relationship. In this case, that okay, the more the ID number or whatever I called it here in this example um increases, the other side is decreasing. Okay, and I mentioned that this was actually the method. I think where we had a lot of troubles was in organizing our data to fit in, right? Hello, hello.
I don't even know, sir.
Okay, you don't know. So everything I've said so far is clear, right? Everything
I
I've
don't
said so
know.
far. You don't know.
It's clear. It's
Okay,
clear.
no, it's
It's
fine.
clear.
No, it's fine. If you have questions or you want me to repeat anything, it's fine. This is our final class now. So it's not like the official lesson. So if there's anything that is not clear or you want me to take my time to explain further, it's okay. I will go over it as many times as possible. So do you want me to go over this again?
The thing
Yes, sir.
actually needs exactly the
Yeah.
thing actually need time.
Okay. Um.
Yes,
all
sir.
right.
Okay.
So, all right. So up to this line, you get what is happening here. I remember I told you pandas data frame would help us to organize this in tables. Okay. So if I did something like student info, do I have pandas imported so that I don't get an error? If I run something like this, is it imported? All right. All right. So and I told you that pandas is going to like organize this for me as 1, 2, 3, 4, 5, 6, 7, 8. Then we're going to have the grade. Okay. Then I said that we used NumPy to because obviously, if you remember basic Python, this is actually a list. It's just that it is a list in a list. Okay, so this is actually a list. Then we want it as an array so that we can um, carry out mathematical operations on it, right? I mentioned that with NumPy, okay, the mathematical library, we convert this to an array or more precisely a numpy. Let me put it as a numpy array. All right. And I remember I showed you the difference when I did something like okay, let me just do that for you again. If I do, if I see test example, and I do np dot as array, I should be able to pass in my list there. One, um, five, six, seven, eight, right? And I see if I print our example right now, our example right now. Um, okay, so we have it like this, and I do example times two. Okay, do example times two. Okay, you have 2, 4, 6, 10. So it's going to actually multiply each value by 2. And I remember that if you remember from list, if you do it as a normal list, for instance, it's just going to duplicate the list. I don't know if anybody remembers that. If I say list, if I now, let me just do something like example. Just to list, right? Start. Let me see if it's going to work. And call the list method on that. Okay, yeah. So if I convert it to a normal Python list with this method, you see that it just duplicates the list 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, 6, 7, 1, 2, 3, 5, 6, 7, compared to when it was a non-pi array. Okay. So, and I mentioned that we wanted to do something like that. We wanted to convert it to an array because we will not be able to do linear regression on it if it was that way. Okay. Then the idea between the panels data frame is we have students, okay, which is a key. So we create a table with dictionaries, just like how you do it in Django. Okay, we use dictionaries to actually when we write our models in Django, for instance, when you are sending that, if you remember the templating system, and you are sending it into maybe your HTML format, you have to send it in as a dictionary. And even when you are querying it, it will still return it to you in form of a dictionary per se. So it's the same general idea. So we have a student key, and its value, okay, is a list of students. Then you have the ID, and we can target the first element in our array, then target the second element in our array. Noting that it is we have fixed it in. We have turned it into a numpy array. It is not just a list. It's now a numpy array. So with that, you can easily you can ignore all of this. This was just to do some work so that to look cool. Okay, so that we can signify that some students passed. But what we were doing here is just setting some conditions. Okay, so there's a method called concatenation. It is called concat. Okay, basically I want to add a column into it's just like how you do normal concatenation with Python. So let's say you have a string, something like print is and you do something like well, let's say string. Let me just say 5. If I do something like this, you can see wisdom 5. Normal string concatenation. So that's just the general idea. I'm saying that I've created this series or this table, okay, that helps me, that gives me an array of if students of people that scored more than 50. Okay, that scored up to or more than 50. And I'm saying that once I have this array, so let me remove this so that you see what I'm saying. If I print out passes, okay, it will give me a table of a single column. Okay, can you see that? True, false, 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 right? It's going to return it in this format. Now I want to take these values, okay, this particular true values, and I want to say, okay, pass it in or concatenate it, okay, with the same general idea with normal concatenation in Django, where I'm giving it the place I'm sending it to, which is the student info data frame. Then I want to rename this guy to pass, because if you look in here, when I printed the passes, you can see that the name is grades. Okay, if I don't give it in, if I don't pass in this rename variable, for instance, if I do this, let me show you what I mean. Okay, and I print out student info, and you can see I have students ID number, I have grades. Okay, okay, it's not okay, sorry. passes. Yeah, I think I should. Mhm. That's the error. Oh, oh. Okay. If I just okay. So this is what I was saying. 9:31. So this is what I was saying. So this is where the error was coming from actually. If I remove that and I just have passes, I think I should get that error again. All right. So you can see that I have two tables called grades. You can see grades. Okay. So because I don't want it that way, I'm doing a rename. I want to rename that value and I want to say if the student pass. Okay. So it's a change from grades to pass. All right. Then the next thing I want to do right now is to so the reason why I ran into that error previously was because I had two tables called grades and it was confused. Okay. So what I'm now doing is SciPy, which is also another mathematical library or a scientific library, because if you can do other can carry out other scientific methods on it, like some chemistry calculations and physics calculations. Okay, but we are just doing normal statistics here. It has a statistics library, so you can see from SciPy import stats. Okay, you can see this module contains a large number of probability distributions, summary, and frequency statistics. Okay, and from there, I'm not saying that okay, it has a method called linear regression. It's actually a linear regression method, and it's going to take in two values, the x and the y value. Okay, any questions so far? Hello,
No, sir.
are you sure it's getting more clearer at this point?
A bit, sir.
All right. So now I know in that class we did many things. Okay, we did normalize data. We even I went further to show you how to plot the graph. Okay, but let's just stick to carrying out the linear regression with this linear regress. Now, what should call this method, for instance, what should call this method? The way I have a result is equals to st dot linear regress. Then you pass in the two values. So I want my ID number, okay, or in the other time it was more like study time. If you change this to I think it was study time we used, right? Study time. And study time. Okay, so I want study time to be my independent variable. That is, it's not dependent on anything. So somebody can have a study dependent, a study time of whatever time he likes. Whereas the grade is a dependent variable. That is, we are assuming that the study time is what affects your grade. Do you understand? So we expect that whatever study time you have, two people cannot have the same study time. So we're assuming that those differences is going to affect the grades in one way or the other. Assuming we had more variables, let's say study time, and let's say maybe gender, for instance, you can fix it in. But if I do something like gender, it means we are going to do a whole lot of a lot more we're going to do something much more different, okay? But it's not within the scope of this particular lesson, okay? But the general idea is if we are doing something like gender, we need to be able to encode it in a way that maybe the male gender will stand for zero and the female gender will start for one, okay? So we can now have something like we're calculating something like maybe a mean um, a mean value. Okay, that you can say that okay, more males tend to study more, which means they tend to get higher grades. or more likely females study more, then which means they tend to get more grades. But let's just leave all that drama. But let's assume, apart from study time, let's say we have something like age. Okay, that might be a very good example. We have something like age, and we are now saying that okay, maybe the age might be a factor to whether a student performs better in a particular class. So let's say in a child, let's say in SS2, you can assume that the much older children, let's assuming that they are more matured, okay, are performing much more better than the younger ones. Maybe because the younger ones like to do more things like play around, laugh, they get easily distracted. But the older children, which is not mostly that's not really a real life scenario, but we expect that the older children should be able to be more responsible, more sensible. They should be able to handle information or read much better and understand more better. Then, apart from reading and understanding, we can assume that they'll be able to write down their thoughts in an exam much more better. So, those are how we can have more different variables that can say affect the grades. Do you understand? Ah, Jesus. Do you understand? All right. Okay. Thank you very much, Michael. All right. So generally, this is how we do a linear regression with SciPy. What you do is once you pass in the command this way, you have to determine what is your x and your y variable. So in the example in real Python, our dependent variable will probably be something like the house price, which will be our y, and where x will now be whatever things that we are using as to the features we are using to compare. So we can have number of bedrooms, the toilet, what type of toilet, is it a WC, is it a pit or train, um, the kind of kitchen, what's the size of the kitchen, is it big, is it small, is the parlor spacious, is there a dining table, what is the direction of the wind? Some people care about those things, ventilation, um, how easy it is to get to go there, then get to the main road, and all of that. The distance from the city. Let's say you have other things like distance from work. Okay, how far is that place to your working place, or if you are maybe parents, how far is that place to your to the school of your child, and all of that. So you can keep having a whole lot of features that might possibly um, affect the prices of an house. Now, with if you notice that with SciPy, okay, because we are doing a very simple example with SciPy, we are limited to two variables, x and y. Now, if you are moving further to use something like skitlearn, which might be what you would have seen online most times, something like is sklearn library. Did anybody encounter that in trying to solve that problem?
Yes, I did. All the tutorial I was seeing was using SQL.
sklearn. Yeah, sklearn. Now, the reason for that is in a real life scenario, when you are doing a linear regression, you usually have more than one independent variable, right? Do we
Yes,
get?
sir.
Yeah, in this case, however, we are using just one, which sometimes will not provide accurate data. So let me see if I can pull up something with sklearn for you and just explain. I have one. Well, we weren't actually, I'm not actually meant to introduce that yet, but I'm coming. Give me a moment. House price. Is it this one? No, I don't think I think it's this guy. Not this one. Okay, but okay, I can use this as an example. Actually, to use this as an example. Come in. Sorry, give me 15 minutes. What is it, my moment? Let's see this one. Okay. I'll go first. Well, let me just use let me use this one. All right. Let me use this one. Though it's not linear regression, but be able to use this as an example. Let me see if I showed out all of the data I was using. Um, okay. All right, so let me just use this one to show. I should have a simpler example. Okay, but let me see. Okay. All right, so sorry about that. So as I was saying, in a real life scenario, you would I would like you guys to actually read this stuff much later on, but in a real life scenario, you would have to probably be able to say that okay, multiple things might affect performance, okay? But obviously, because it was an introductory lesson, I expected you guys to. That's why I think someone asked me, and I said, I know you are having a table with multiple data, and I told you to pick out two columns, okay, and let one act as your independent variable, and let the other one act as your dependent variable, so that it keeps your assignment simple. Okay, but obviously online, you actually find more of real life scenarios where you have more than one data in your data set. So let me show you this example. Okay, so this is a house prediction data set. So I don't have this data set right here, but I have it loaded in from here. So I can do something like this. Let me see if I can do this right here. Let's see. Let me comment all of this out. Let me comment all of this out. Yeah. Let me see. Let me print. So let me run. Alright. So let me see if I can. No library name Sigon. Just just, very sure I have Sigon installed on my system. Okay, wow, interesting. Okay, let's see. It's gonna work now. Um, okay, let's do post. Uh, Sorry, I think I ran this in my virtual environment. I ran this in a virtual environment and so I don't have the database installed. Okay. Oh, it is where it is running from. So, code library, even this. Sorry, let me just activate this guy. Activate, sorry. Alright, I'm gonna run this again. Hopefully it works fine. Um, okay, let's go. Alright, so this is going to take a while to install. So let me just go back here and try and show you what I was saying. So let me comment this guy out. Alright, okay. All right, so you can read the documentation to see which version is. You can fetch data from the original source, all of that. Okay, so I'm trying to get the columns. Okay, bring out data, columns. Let's see if that's gonna work. I have where I dropped the price here, so I'm not seeing that price. I'm seeing sorry. Oh, is that price here? There's no price. Age, distance, I think tax, and the something like that. Let me just copy all of this and let me see if I have the table. Okay. Let me go to cargo and get that mouse. And sorry, system. All right. I think I have the data somewhere. Okay. Okay. I think this is done. Is I'm not getting the data. I don't want to show it to you
Sir,
this way.
sir,
Yeah.
I get the insurance CSV file you give to us. So it has a lot of table.
Yes, but I don't have a code that shows this one. Okay. So okay, okay, all right. So I think I have what I need now. Okay, so let me just print out this guy and bring it down here. And I think I should have a better data representation right now. Okay, yeah, so we have something like price right now. Let me print out the data so that we can see it. It's been a while till I opened it. So this one I was the one that added the price column. All right. Okay, so we have something like this at this point. So you can notice that we're having data running down to 505. Okay, up to 505. So if I do something like dot egg, I think it should work. To the first time. Okay, I have first time. Right. So we have other variables. So we want to assume that right now, um, we want to assume that right now we have the price, the so okay, let me just make things clear. The reason why this is looking like this is because I didn't download the CSV file. Okay, I loaded it directly from the skill and library. Do we get it? Do you get what I'm saying?
Yeah, yes, sir.
So I'm loading it directly from. So that's why you're not seeing something like read like something SV. And this target method is something in the data set that is actually the price. So they've actually already splitted it in a way that when you see something like dot data, you get this is like the independent variables, like all these CRM, ZN, industry, and all of that. They all stand for something. Okay, while this target is actually the dependent variable, which is actually the price. So what I did was to create a what's it called? To create a key called price, and I want to say these values, okay, should be in price. Do we get just for clarity's sake? Let me print out right. Let me print out on top, yeah, so that you can see what I'm saying. So you see that, yeah, we're just going to get a list of values. Can you see? 24, 21. These are all prices of houses. Do you get?
Yes, sir.
Are we sure? I think the file should have downloaded by now. Okay, still downloading. Okay, download. I think should be here. And download. Download actually. Okay. Okay. So let me open this with this spreadsheet package. Sample selection. Open with um, okay. All right. So this has been worked on. So test test data. Open with the replace now. Sorry. Yeah. Okay. Okay. So this is what I was saying. Now you can see that this is how the data looks like in if you download the file. Okay. Now if you notice that the prices are not here, can you see? Because this is the test data, and so we are going to use this to know if our app is if our program works properly. So this is what we need to look at. So this should contain the prices. Yes, this is containing the prices. Okay. All right. Can we see this clearly now?
Yes, we can see it clearly, sir.
All right. So so far, so let me just start again. So from here, from down here up to this point, these are your dependent variables, right? Independent variables. These are the things that can affect the prices of an house, of a house. Okay. Now you can start removing things like we may not have something like address. Okay. All right, but you can take in other values and you can see that these are the prices in whatever currency this is. Okay, now this is like a training data, so you have this like a standard or a template. Now this test is we are going to take these values after looking for a relationship. So the idea is this training data, we take these guys, okay, find some form of relationship, find determine some kind of formula or finding some kind of pattern that will give you some kind of formula. Okay, now it's the same idea with doing something like what we did in the last class, like in the actual lesson, where when we add the linear regression itself. When we did the simple linear regression, we now add something like the slope and the intercept. Okay, and I remember that we gave this formula that y is equals to mx plus c, something like that. I will now say that we can always put in values and use it to find out, just like the way we do in secondary school. When you've plotted a graph, then you now say, what if the price what if the price is 55? You will now go to your x on your x, go to 55, then be tracing it up till you touch the line. I don't know if anybody remembers that process in school. Does anybody remember that thing? Okay, I think we remember. We're running out of time. So once we are able to do that, once we're able to train our model with this, we'll be able to carry out a get prices for this. So which is the idea, but that's not what I want to show you. Now I was saying that in a real life scenario, okay. So I'm saying that this target is the one that contains the prices, while this data is everything else before the price. Okay. If I print out data right now, we'll get something different. We won't get the price table attached to it. Okay, so we're having it on all the grammar this way. If let me remove the data before, because it's going to give you a list also. So let me just remove the data and let's just print out the data sets. It's not gonna work. Needs it. Yeah, it's data. Okay. Okay, it's loading. All right. So what I've done so far is to we have it loading. All right. Now what we've done so far is to what I'm doing here is to append this guy, this price to the overall data so that it's all is in the same idea. Now what I was saying that in a real life scenario we will have multiple things that affect a particular thing. Okay, so multiple things can affect the price of a house, for instance, and you can't start doing things one by one. So they say you now do first for the road, for the tax, for the electricity, all of that, and all of that one after the other. Okay, what if you have a very long table or you have a very long data? So you need something to be able to undo all of this at once and run it for you quickly and you get your results. Okay. So that was why you notice that most of them were using scaling, because most data you don't just have two values, one y and one x. You probably have multiple things that you are using to compare. Okay. So an example of what happened was this model regressor. I think my this should have finished running. Yes, it has finished running. So I should be able to do this one now. All right. So ignore the plotting of data. That's not really what I want you guys to see. So let's quickly come in here. So obviously, when I say x dot drop, I means I want to remove the price label because x is just our column and y is our dependent variable. So you can see it as independent variables. Okay. Um, I'm going to do something to help us see that it's much better than X. Okay, so okay, let me remove that print statement that I have and stuff. Okay, I've removed it. Right. If I print X line 33, okay, at this point, um, okay, NS not defined, line 26. So let me comment all the graphs. So I have a lot of things I have not stored in this place. Okay, let's remove all the graphs. So I'm not plotting graphs. Okay. Yeah. Okay, so we just want to see what happens when you do the linear regression. So I think we're good. It's taking a while and give the moment. All right. So if I print out X, for instance, you can see that I don't have this price table here. Okay. So everything but the price is going to be part of the x value, which is the independent variable, and while y, for instance, is our dependent variable. Okay. Want to see what happens to y over different kinds of issues. So far, do you have any question? Hopefully you do. Um, so far, any question?
Oh, so so you are saying that our S value will determine our Y value, right? Like
Yes. Yeah, that's what we are doing. Want to know how x is going to affect y.
Y.
Do you understand? Do
Yes,
you
yes,
get?
yeah.
Now I'm now saying that in the one we did in class, we had only one x table now, Adi, which was the Wait, which was the time students used to read? The study time. I been now
Yeah,
for each student.
yeah, that day I was not actually in class. So
Oh,
yes,
so in the class, in the example we had in class, we had only one table for X, which was the amount of time students studied, right?
yeah, yeah,
Which was the example. That was the simplest example. Now, on going to your research, you found out that they had a whole lot of tables that they were running at the same time. Abi?
yes, yes,
Yes. So what I'm saying now, in real life scenario, the
yes,
amount of time a child studies is not the only factor that affects if the child will pass an exam. Abi?
yes, yeah, yeah,
There are other things that affect a child. So I'm not saying that in you are a developer, you obviously don't want to now start taking each of those variables and be comparing it and seeing how it affects the grade one by one, right? You don't
yes,
want to say, let me do the amount of time the child study first. Then I will now say maybe the child is happy and you get one after the other.
yes,
We
yes, sir.
need a way to take in all those things that can affect a child's performance and use
Yes,
it at once to determine the child's overall score at the end of the year.
yeah, yes,
You
yeah,
understand? So that's what
yeah,
we are doing now is skilling. So what we are doing is we are taking that data now, pulling
yeah.
it together. We have it in one spreadsheet. Okay.
Oh, okay,
Now, so with skilling, what they actually do is machine learning.
okay,
It's machine learning. So we're already moving outside the conventional, let's just do a simple linear regression. So they have
okay.
something called models. So they are machine learning models. They've been developed to handle this kind of problems. Do you get?
Yes, sir.
Or when you say machine learning, it's basically computers or models that can learn from data.
Yeah, yeah,
You get? So the model is going to look at the data you are giving it and it's going to learn from that data. So from that data, it's going to find patterns or similarities, find a strength, or determine some kind of formula from all the data it has.
as yes,
You get? Then
yeah,
with that data, it can now say that because the data you are initially going to give it, okay, that we call that supervised learning. Is actually going the first set of data is actually going to contain the price. Do you understand?
yes,
So this is what you are doing. You have the final results, Abi.
yes,
You have all the things that affected the final results.
yes,
So what you are going to do is you want to develop a formula from that data. So you are going to look at all the things that affected the result,
mm,
develop a formula that will always give you that price.
mm,
Abi?
yes,
It's
yes,
going to give you find a pattern that will give you that price. So
yes,
that when you give it data or when you now encounter new information, you can easily just plug in those new values into the formula you've already developed as your guide or your standard,
oh, yeah, yes,
and
yes,
say that okay, that means and say that based on information I've learned before or based on the pattern I've learned before, this child that studies for this time has other factors affecting him, is probably going to have this particular score at the end of the year. Do you get?
yes, yes.
You got? So that's all the things I've been trying, that's everything I've been trying to explain since.
So it's one only one thing that cause the effect. It will be maybe someone having multiple values that may
Yes,
lead to the result. So
yes, that's
maybe
what we are saying.
yeah, I understand, sir. Now. I understand.
So in this in
It's just that
okay.
it's just that the method we are going to use to get the multiple or in the case yeah,
In the case scenario for the assignment, okay, I mentioned that use only two variables, two values. Okay, let one be your y and let one be your x. Is an introductory lesson, so I wasn't expecting you guys to try and pull in so much data at once. Do you understand?
awesome.
So what I'm doing now is trying to explain what you say in most examples online. Okay, so you can see that when I printed X, you can see that I have very a lot of data, okay, that affects the price of the house. Do you understand?
Yes, yes,
Yeah, so these are everything. In what I expected from you guys was to pick out just one of this guy. You get, let's say
Yeah.
this CRM, and use
Yeah.
it to compare what happens with the price of a house.
Okay. Yeah.
That
Yeah.
was
Yeah.
what your assignment was meant to be,
Yes.
but it's
That's what
fine.
we did.
So
That's what we did.
yeah, okay. So in
That,
explaining, you now have this whole lot of data, right? Now what we are now going to do is, because we have just one data, we want our system to learn from it. This is what we are going to do. We are now going to divide the data, right, into a training and a test. What is training? The training data is going to contain the features, like I explained, that affect the price and the prices itself. Okay.
yeah. Yes. Yes, sir.
While the test data is just going to contain only the features that we